Hi everyone. So in this video we'll look at the AWS integration services, basically messaging and event driven architecture. SNS, SQS, EventBridge and AWS step functions is what we'll look at. We'll look at the concepts as we are doing in the previous videos. We'll look at the features, major features, what it is best for, what it is not that ideal for. So these are the points we will discuss for each of these services and take it from there. Let's start with SNS. So simple notification service. Before I start, let me tell you that we have this AWS builders and AI community for people who want to learn and have a community of their own on AWS. They can join this. Just register. There are few basic details you need to fill and we will onboard you. It's about learning with the peers and making the network work for you in whatever way, shape and form. It's always good to connect with the community in terms of the work you are doing, right? So we are trying to create this inner circle, and if you like it, you can join that. Coming back to SNS, so it has, it's a fully managed real-time messaging and notification service. So you have to send a message or a notification, you can use SNS. It's push based. It provides message filtering, fan out, durability, encryption, archiving. It is best for, let's say there is an event and you want to notify multiple systems. Always think about SNS if that is the use case. And this notifying many systems, that is also known as fan out pattern. Okay. Obviously you are sending alerts or notifications and basically triggering multiple downstream services on that event. So as that event occurs, you are trying to trigger multiple services downstream, right? So it is not ideal for if you need ordering as a key constraint. Then SNS is not something which you should go for. Obviously not message buffering. There is no buffer here, and anything which you want to retry, that also you should avoid. So retry heavy processing is something which you need to avoid. One analogy which you can think of in terms of SNS is basically, let's say you are trying to announce with a loudspeaker. So there are multiple people who are receiving that announcement, correct? So think of SNS in that same way. SNS versus SQS is something which people should know. So let's look at SQS now. It is simple queuing service. So basically you are trying to decouple a tightly coupled architecture with the help of SQS. Okay. And it is pull based, processes workloads asynchronously. It's a asynchronous service to service communication, and you have guaranteed message delivery. Okay, processing is done at the end by a consumer, which fetches the messages by a concept known as polling. Okay, so the consumers would keep on polling the messages in the queue, based on their capacity. So if you have to decouple application components, go for SQS. If there are sudden traffic spikes, you can queue those new requests, and the consumers would process them as and when they have the capacity, and your message also won't be lost. Okay. So this helps when a particular workflow or the processing cycle takes a longer time to complete. Okay, so what you can do is you can put the call in the queue, and the consumers would keep on pulling them asynchronously as and when they want. Okay, and the message keeps on being in the queue, which is also known as kind of buffering. Okay, so if you need reliability and buffering, go for SQS. SQS analogy would be something like a mailbox, where you keep your mails in that box, and as and when you get a chance, you try to collect those posts from your mailbox, right? So mails or physical posts or even inbox, so the mails keep on coming, right? So and as and when you get a chance, you read those emails, so the mails still remain in the queue, correct, before they are read. So think of it in that way. And it is best for, if you want, if let's say the there are messages in a batch of 10, and a message is getting failed. So what you can do is you can try to you can also have retry mechanism in place to again process the set of messages. Okay. So that's how SQS works. There are two types, standard and FIFO. In standard, it is delivery at least once, and order of delivery may be little different. It's high throughput, so the messages would want to get processed fast. In FIFO, it's delivered exactly once, same order, and low throughput, because that's the trade-off. So here throughput would be lower because you are trying to get the messages in the same order and getting them delivered exactly once. There is also something known as DL queue, which is nothing but a separate queue for messages not processed by consumers, okay, or the failures. So let's say multiple times you have tried, even after retry, if a particular message is failing, then you can have a configuration where that message is placed in DL queue, and you can revisit that later. It's known as dead letter queue, delay queue, a normal queue with a custom delivery delay setting. Okay. And what is a temporary queue? It's a lightweight queue that is auto deleted after use. Okay. Okay, now let's look at what is visibility timeout. Now visibility timeout is nothing but the amount of time a message remains invisible to other consumers after one consumer has picked it up before the message is deleted. Okay, so when a consumer has picked a message from the queue, you don't want another consumer to pick that same message to avoid the redundancy. So the message gets hidden once it goes to a consumer, and it is only reappears again in case the first consumer is not able to process it or the processing fails. Okay, and it exists because SQS is designed to ensure messages are not processed by multiple consumers simultaneously. And yeah, that's what I mentioned, right? So you have this concept of visibility timeout in SQS generally. That is also known as a message retention period. It is the amount of time SQS keeps a message in the queue before permanently deleting it, regardless of whether it has been processed. Okay, so it's like the total time period, total retention time period of a particular message. Okay, so that is message retention period. Default is 4 days, minimum is 1 minute, maximum is 14 days. Okay, regardless of whether it is processed or not, you have a period for which the message is kept. Okay, after that it is deleted. Receive message wait time. It controls how long a consumer waits for a message when polling the queue. Okay, so the consumer keeps on polling, okay, to see if there is a pending message which it can process. So how long the consumer needs to wait for a message when polling the queue, right? So it polls, waits, and then after a while it polls again, right? That's the idea. SNS versus SQS. Now let's look at the difference between the two. Order is, you have SNS topic, you have email, lambda, SQS. So basically idea is that there is an order, there is a SNS in place, notification service, and the order goes to each of the three different services in email, lambda, and SQS. SNS you publish and subscribe, it is push based. Okay. SQS is pull based. You have a producer, SQS, and consumer polling the queue. Okay. So in SNS, the messages are published and then subscribed, and it is push based. Okay, there is no polling there. Message sits in the queue, which is the meaning of buffering. Consumer asks, do you have a message? Consumer decides when and how fast to process. So it is pull based. So consumer has the control in SQS, and this queue helps smoothen spikes as consumers control speed and prevent work overload. And this queue helps smoothen spikes. As I mentioned, consumers control speed and prevent overload. Okay, even if the consumer is down, messages stay, no loss. Okay, so what happens is, let's say there is a spike, so the message is at least in the queue, and consumer can take it up as it gets a chance, or as its capacity allows it. Okay, so if it is busy, obviously it cannot take a message. So once it has the capacity to take the message, it can take it. The messages would stay, so they are not lost. And many consumers can pull independently. Okay, that's the scale. So it is totally scalable. So analogy you can think about is SNS talks, SQS keeps on listening. Okay, let's look at EventBridge. It is another quite a renowned service in AWS. It's a serverless application or service. First of all, event bus service, serverless event bus service, obviously event driven architecture. Here you can put various rules to route the events. It's mainly used for service to service integration. Okay, so there is an event, there is a rule. Based on the rule, the target is identified, and the message is sent. It's ideal for AWS service events. Natively receives S3 events. So there are events coming out from S3. Okay, based on, let's say, a new object coming in, or an object deleted, object updated, whatever. So you can configure S3 events, and then via that event you can trigger an event bridge on that event. It can be used for SaaS integration, pattern based routing, event filtering. So you can have some filters in the events, and it routes to multiple targets. If events come from AWS services like S3, EC2, and you want decoupled microservices, okay, then you can go for EventBridge. It is not suited for simple queue buffering and high throughput job processing. Okay, this is one of the main things in EventBridge. Okay, AWS Step Functions. Now AWS Step Functions is a workflow orchestrator used across AWS services and microservices. So you have visual state machine for designing and monitoring these workflows. Okay, there are built-in retries, error handling, and timeouts, and there is conditional branching, parallel execution. This is mainly used for long running workflows with persistent state and execution history. Auditability and observability with detailed execution logs. Okay, and it is best for business process automation, approvals, claims, reconciliations, order processing. So let's say you have a particular event coming from S3, and on that event you want a particular workflow to happen, right? So let's say you want to do contract review. Now let's say contract is getting uploaded to that S3, and then you want different agents doing different workflows to complete the review. Let's say first agent is about ingestion, second one is about risk analysis, third is about compliance or compliance and risk in parallel, whatever is your flow, and then finally a decision agent. So if you are doing, let's say, this kind of a workflow with multiple steps involved, AWS is an ideal candidate for orchestrating these different agents, okay, and these different multi steps. I gave you an example, hope that is clear. And ETL and data processing pipelines, AI ML pipelines, workflows requiring retries, checkpoints, and audit trails. Okay, so there is you have to configure one ASL file which defines what happens to like how the different steps are connected to each other, and how the retries happen, and so on and so forth. So you can provide all that configuration. And it is not ideal for ultra low latency systems like chat, gaming, trading platforms. Not very ideal for very high throughput event streaming. Okay, simple single step processing where lambda or SQS alone is enough. It is not ideal for very simple single step processing. Why you want to use such sophisticated orchestrator when your step itself is very simple? So obviously ultra low latency won't be handy here, because multiple steps are getting involved. Okay, and large scale data crunching loops. Okay, so if there are millions of iterations, then also this won't be an ideal candidate. Yes, so let's look at the integration services in a diagram. So typically, let's say there are various events coming, like scheduled events or external integrations, as you can see on the left side. Then you can have an EventBridge there, which would, based on the rules, match different events to, let's say here, fanning out to SNS, or starting a workflow in terms of AWS step functions, right? And then at the bottom you see Amazon SNS. So fan out to SNS is happening, and let's say if the fan out is on a topic and you have different subscribers to that topic, so the subscribers could be in form of email or SQS queue, right? And then that SQS queue in turn can have consumers like worker A and worker B, which are consuming the messages. So in SNS you have two subscribers, one is the queue, one is your email or webhook. Okay, they are subscribing a particular topic. Based on the rule, specific events are sent to SNS, and based on the rule, another set of events are sent to another workflow which triggers your state machine, that is AWS orchestration, AWS step functions, which is the orchestration service. So that's how these services can be used. We saw how EventBridge is able to route the events based on the rules to different services. Fan out to SNS is one example. Then starting step functions is another example. And inside of SNS you have a topic on which subscribers are subscribing. One subscriber is SQS queue there, and then SQS queue you have consumers like workers A and B here, both are lambda. They are polling the queue, and the few messages which cannot be processed are going to DLQ, and so on and so forth. So hope this diagram helps you understand the different integration services in detail. That's it for this one. I'll see you in the next one. Thank you.